Hello and welcome to our October session of office hours. My name is John Kowalski. I'm part of the marketing team here at Bitgardner, and today we're talking transmission haze and clarity. Our presenter is Mr. Mike Peters. He's our regional sales manager for our Canada territory. Also, if you're unfamiliar with our office hours format, we'll begin with a shortened presentation, usually lasting 20-25 minutes or so. And then it's followed up by your time. What questions do you have? What challenges are you experiencing in your own facilities? And how can we assist? So if you do have a question, please enter it in the chat box. Should be in your bottom right-hand corner of your screen. And we'll get to that following the presentation. We are also recording this, so immediately following, you'll receive an automated marketing email with the link. Feel free to check it out later, share it with colleagues, whatever you like. So with that, I think we'll get started. Let me introduce Mr. Mike Peters. It's all yours, sir.
Thanks, John. Just to make sure that you can hear me okay?
Yep, loud and clear. Thank you.
Excellent. All right, well, thanks everyone for joining. I guess I wanted today to talk a little bit about the transmission of light through a surface and some of the influences that there are that can affect how much of that light is transmitted, how much is deflected, and some of the properties of the sample that can affect that. And then we'll go into a bit of detail about some of the methods of measuring that transmittance of light. And and then if you have any questions, feel free to ask along the way. So I'll start by just talking a little bit about the product itself, and obviously depending on what product that we're manufacturing, it will determine how much light we need to have transmitted through that medium. And good examples of samples would be glass for solar panels, or glass for tablets or cell phones, or computer monitors, or film for food. They all should be as translucent, as clear as possible, so that we can see things perfectly. Other industries may not have the same requirements. Maybe we need to have a little bit of haze, for various reasons. I'll start by just talking about how we objectively qualify how much light is transmitted through a sample visually. And one of the things that we would always recommend is that depending on for visual evaluation, that we recommend that you use behind the sample an object that has bright patterns, dots, lines, with a dark background, so that we can evaluate it properly. Of course, perception is going to be dependent on the illumination and the observing conditions as well. Oops, went the wrong way. Sorry about that. If we consider a homogeneous material with a smooth surface, you're going to find that part of the incident light is actually reflected by that first and second surface in the specular direction. So you're going to see, and hopefully you can see my cursor, but you're going to have reflection from that first and second surface in that specular angle. And in this particular case, because of the fact that there is no that the light is directly transmitted through the specimen without scattering, through that sample without scattering, the sample will appear glossy and crystal clear. Now, the portion of the light that is reflected versus the transmitted portion, that'll be determined by the refractive index of the actual sample itself. And because the transmitted light isn't disturbed or scattered by particles inside or by the surface, the sample behind that will appear crystal clear. Keep in mind that the intensity of the transmitted light will be diminished by light being absorbed by the material, either by pigment particles or by colored dyes, etc. In this particular example, we can see that the light is diffusely transmitted, and it changes the appearance of the the appearance quality of the product that's behind it. Now, this particular phenomenon can be a result of surface structures. It can also be a result of air enclosures or poorly dispersed pigments or dust enclosures or crystallization. So you can see that the object as a result is very unclear. It's not as crystal clear as in the first example. Now we can start talking at this point a little bit about the effect of the inclusions and how their characteristics will affect the scattering of light. And we found that the particle size will influence the way that the light is actually scattered through that sample. You can see that in the first case, the top case, you've got a very small particle, and the incident light is diffused in all directions. And as that particle size increase, more and more of that light is scattered towards in the forward direction. With a sort of a narrow cone. Now, this is important because this brings up a couple of terms that some people may confuse from time to time, and those are haze and clarity. Now, we'll talk a little bit about just the influences of how much that light is scattered. We can categorize it two ways. One is wide angle scattering and the other is narrow angle scattering. And by narrow angle scattering, I'm referring to the scattering of light that's less than 2.5 degrees. And you can see that just by the pictures on the screen that it does play a role in how we actually perceive a sample behind that, or an object behind that sample. And this is where we get into the definition of haze and clarity. Haze, and this is as per ASTM D1003, it defines haze as a percentage of light in which when it passes through a sample, it deviates by more than 2.5 degrees on average. Clarity, on the other hand, deviates less than that 2.5 degrees. And you can see one of the most important things about these two is that in the case of clarity, you can see that the object, the object's distance from the sample plays a role in how we perceive that object, whereas in a wide angle scattering, distance from the sample doesn't play a role. So we've talked about total transmittance being sort of broken down into 3 distinct areas where we've got direct transmittance, we've got the narrow and wide angle scattering, which we now call the narrow being clarity, the wide angle being haze. And now we can talk a little bit more about how we actually will measure these properties. So here we have a setup where we have a box with a source of illumination. We have a lens that collimates or straightens out the light beam into parallel rays. We have a sample, and then we have that sample, the light passing through it and scattering into a sphere that's coated with a white matte material. And you can see that there is a light trap at the back of this sphere that is closed. and a sensor up here that is turned on. And essentially, for total transmittance, we're looking at how much passes directly through, how much is scattered, both in that narrow and wide angle. And so the light will bounce around in this sphere, and it's called an integrated sphere, and it will, and the sensor will detect the light that gets through. In the case of haze, what we're doing is we open the light trap so that any of that narrow angled light, scattered light, actually gets trapped in this port here. The rest of the light bounces and gets to the sensor. And as a result, we're able to measure the amount of haze. And you can see the calculation for haze here in terms of a percent. And then, of course, to measure clarity, we're now closing the sensor at the top. We're opening up the sensor at the back of this narrow angled area. We've got a center sensor and we've got a ring sensor, and we can then measure the clarity of a product based on the amount of light that these detectors will see. Now, Vic Gardner has been building these devices called the Haze Guard for well over 20 years now. And, there's been some improvements over the years, starting with some of these that, well, we've made some improvements, let's just say, over the years. And one of, if I can just show you, one of our newest improved products is our Haze Guard Eye. It has a really nice open design. It's quick and easy to change and position samples. There is no influence from ambient light. It has a bunch of different holders to hold different types of panels, from the one that's shown here to thin film holders. If you have some thinner films that you need to stretch to make sure that you have it wrinkle free when you're doing your testing. Yeah, this particular one can be used either sort of horizontally or vertically, depending on the type of sample that you're measuring. So, optically clear Petri dishes with liquid can be used on this particular type of sample as well. One of the other nice things about it is it does have, it uses high performance LEDs that have a 10-year warranty. So it's a very stable light source, and and certainly that, we have devices in the field that have been in the field forever. It's an incredibly robust and versatile piece of equipment. It does have automatic calibration and self-diagnosis. It does have a reference beam for ISO measurements, very repeatable results. And if you're working in a company that has multiple facilities that may be measuring at each of those facilities, the inter-instrument agreement between the devices is very, very good. So you know that when you're comparing results from one facility to another, that that you're comparing apples to apples. So it will measure to ASTM D1003. It will measure to ISO and both the C and A illuminance in the non-compensated method. It does also measure the to ISO 13468 for D65. And one of the nice things about it is if you do require measuring in all of these standards, you can actually have the screen set up so that you see everything all at the same time. It does come with 2 licenses for the software that we call Smart Chart, which allows you to download all of the information into a place, and you can keep track of it. You can look at trends over time. You can maintain standards if you have some in the software. You can also do that on the device itself. You can add tolerances to your standards and then get a pass-fail indicator directly on the screen. That it'll have like a little red or green bar depending on whether it passes or fails. And then from there, it can be downloaded to an Excel spreadsheet, or you can print it out into a PDF, and send that by email. We also have developed a little table for cuvettes, and then we have optically clear glass with 2.5, 5, 10, and 20 millimeter path lengths if required. And then another thing that we have is a Tabor abrasion attachment that allows you to measure according to D1044. And this is just an example of a Tabor test. And that was a quick and dirty description of the product and a bit of the technology. I hope I was clear enough. But if you have any questions, feel free to ask.
Yeah, good stuff, Mike. Thank you very much. If anybody out there, if you have questions, just jot them in the chat box and we can get to them. We've got lots of time left. This is your time. How can we help? Whether it's with transmission, haze, or clarity, or other color instrumentation, Mike's a great resource here. So, question for you, Mike: when you're heading into a client, what are the first things someone should look for when they're looking to actually get into measuring haze and clarity? Are there certain protocols or processes or some kind of steps that they can do to start moving in this direction?
Well, one of the questions that I get a lot has to do with can this measure very, very opaque products?
Yeah.
Because there are some samples out there that don't allow a lot of light to be transmitted through it, and as a result, they're wondering if the Haze Guard is the right kind of device for that particular application. One of the things that we can do is if we're not sure, we can certainly do testing because we have a lab. Obviously, that we have a lab in our Maryland facility that with one of these Haze Guards, and we can actually do some testing to make sure that the product is right for you. But also, if it tends to, or if the sample is too opaque for enough light to be transmitted through it for the detector to detect that light, it may be an application for one of our other products. We can measure things like opacity with some of our other spectrophotometers that may actually be the right product for you in that particular case. It really all depends on the situation, but one of the things, we have people like me that go into the field with these devices, and we can certainly bring one and do a few evaluations directly at the facility.
Yeah, that's a great way. Either send in samples and we can do it in the lab, or schedule a visit with one of our sales managers who can actually run some trials in your own facility.
Yeah.
Got a question here from John. I'll read it here. Hi, I've noticed that transmission results are a little different with the different test standards. Is this because of the illuminant? ASTM D1003 has C or A illuminant, and the ISO has the D65.
Yeah, so the values will depend on what ISO or ASTM standard that you are running with. The values will not be the same for each of those standards, mainly because of the illuminant. So yes, you are correct. It is illuminant. It is a result of that illuminant, either D65, A, or C calculation.
Okay, and he says he hasn't noticed much difference with the haze. Another follow-up question he has: what test standard is most globally recognized? The ASTM CRA or the ISO D65?
In my experience, ISO has been more of an international or European standard, whereas ASTM is being used in North America. And again, if you have international customers or both, North American and European customers, as I mentioned, you can actually set up the Haze Guard so that it's measuring in each of the standards at the same time and showing you the results on the screen at the same time. So, and you can also record all of those results at the same time so that you can, report the correct values to your customers wherever they are in the world.
That makes it easy. That's right. Looking when you showed that part during your presentation, and it only takes one measurement correct, but it saves the data and gives you the data in both of the ISO or the ASTM, correct?
That is correct, yes.
Oh, that's nice.
Yeah, you can set it up ahead of time to measure all or just one of those standards or a combination thereof. And yes, so you can customize the screen to show you exactly what you want.
Excellent. Very cool. Very cool. Got a question here from Richard. What is the calculation from Haze or for Haze? Do you know that one?
The calculation for Haze. So
we can flip back
here. Where is it? Here we go. Haze. Let me just. So Haze is 100% times the total trend or the T diff over T total transmission. So so that's the calculation right there.
Okay, good. Does that help, Richard? And then John, did that answer your questions or help? I apologize for not asking you before we moved on.
And then clarity, of course, is based on what's detected by the ring sensors in that 2.5 degree space here.
Okay.
So IC IR over IC plus IR times 100%.
Perfect. Okay. Thanks, John. Excellent. Other questions out there? Log them in. Are there other frequent questions that you see or unique challenges? I like your point, that we were talking a little bit before is, those strong opaques, I guess. At what point does the Haze Guard stop working and then you shift into a spectrophotometer? Or does that just really depend on the substrate and the sample?
Yeah, I mean, if it's getting close to being the best thing that we can do is test to make sure that we're getting you the right product for your particular application. And I can't give you an exact cutoff point for opacity, when it starts to work and when it doesn't. But the best thing that we can do is just run a test to make sure that it'll work.
Yep, excellent. Question from Richard here. IR and IC are absorbing values?
Yes.
Okay, good. What else you got for us, Richard? I like to. This could be a stump the mic session as well,
One of
too.
the other cool things, I mean, you know, not always necessary, but if you're running long-term projects and want to keep track of product quality over time, you know, the software that comes with it is really, really nice. It's called Smart Chart. You get 2 licenses free of charge with the device. There are no hidden costs. There's no monthly fee or anything like that, and it allows you to log your data directly into a computer, or you can save it on the device and then just transfer it via a USB key if you wanted to do that. But it's really slick. It really works well, and it gives you the ability to log everything, keep track of everything. You can create projects for different samples for different customers. You can maintain standards if you have multiple customers that may have different tolerances. You can keep standards specific for those customers within the software and on the device itself. You know, it's really nice to use.
And with standards too, is if you're looking at multiple suppliers or multiple plants, they can all be working off the same standard, correct?
That is correct. Yep. So
Awesome.
those standards can be emailed from plant to plant so that everyone is running off of the same ones. Yeah, without any issues.
Gotcha.
And one of the other nice things about it is the device is it has a interactive touch screen. So it's very easy to use. It's very easy to get from one project to another. For measurement purposes, it's super simple. And like I said, there is you know, it does go green, or you'll see little green or red depending on whether you know, one of your samples passed or failed according to the tolerances that you've set. So there is a visual cue for operators that you know, whether it passed or failed. And then you can see that as well in the software.
Nice. Question from John here. I just noticed that ASTM D1003 specifically mentions BIC. However, the ISO doesn't mention BIC. If we were to use the ISO standard, do we need to reference part 2, a double beam?
Yes, I mean that's how ours works, is through part 2. And the reason why I mean, we're getting into the weeds here, which is great. But the reason why we're using a double beam as opposed to part 1 is it just makes it a lot easier. It doesn't require you to move a sample from one port to another. The ISO method is also called a compensated method, and part 1 involves having 2 ports where you have to move the sample from one port to the other so that you can. Anyway, it's part 2 allows you to remove that requirement and have a reference beam shone into the integrated sphere, and that allows you to well, it just saves time. It saves a bit of hassle, but it is possible to do with the Haze Guard. I'm You're right that 1003 does mention BIC. But the fact that it's more generic for the ISO test method doesn't mean that we can't do it. It's just an ISO policy, I guess, not to reference companies.
Instruments. Okay. Nice. Minor comment. I wish the new machine had a larger font size on the display like the old machine. Heard that before, Mike?
Yeah, I mean, you know, yeah, I can't say much about that, but I mean, it's one of the things that you might want to do. Geez, I wish I could show my screen right now.
Well, you can if you want to do the share screen.
Oh, here we go. Open in browser. Sorry, I'm just I'm trying to do that right now. Is it
Sure.
screen 2 share? Okay.
Yes.
Uh,
Yep.
so I'm not sure what screen you can actually see, but I'm going to try to. Can you see my screen? Can you see the?
Yes.
Okay, perfect.
Yeah.
So if you go into configuration, sorry, maybe I should start by saying that
Yeah.
this is actually the screen that you see on the Haze Guard. And if you go into configuration and you go to themes, you have the choice of either having a dark background with white lettering or a white background with black lettering. One
Okay.
of those might be easier to read. It depends on the lighting conditions in your facility, but but this might actually help, with the way that it gets seen. That's one of the things that I found is one of
Yeah.
the things that you can do is change that theme.
Nice. No, good suggestion. And John, we'll put that request into, our German engineering team, and the more comments, stuff like that we get, specifically from you all in the audience, the more likely they'll make a change. So we'll keep record of that and keep pushing for you. We want to make these as best as they possibly can for you.
Yeah, and if I can just show, like,
Yeah.
D1003, this is Illuminate C, D1003 Illuminate A, ISO 13468. Haze is ISO 14782, and then our bit clarity. If I click on all of these, you can see that it gets a little busy, but you can actually have all of them on the screen, and then you can actually add your tolerances for each of those as you want.
That's pretty slick. Very cool.
And then, yeah, so if I go into a project, go into a demo project, and then just, I add a measurement, you can see that by pressing the button, it's telling me what to do. And then it gives me the readings, and you can see that it gives me the readings in all of the different, and this is just an example. It's just giving me random values, but it shows you that you can actually get all of the information on the screen at the same time if you want. But you can also just have one standard if that's all you're interested in.
Very nice. Very nice. What other questions do you guys have out there? Log them in the chat box. Like I said, you'll be getting a recording, a link of this. You can reference later. What else? Here, Mike had his email address on the very last slide.
I got to stop sharing in order to.
Yeah, here I can take over for you. There you go.
Oh, thank you.
There you go. Mike's email address right here. Also, any of the automated marketing messages you get, you can simply hit reply. It'll go to someone on my team, and we'll get it to the technical folks that need it, or the regional folks. Question here from Angela. How do you prepare a coating for measurement?
How do you prepare
a coating?
So that will depend on the coating. Is it a dry sample on a substrate, or it really depends on the coating itself. But if the coating is in liquid form, you'll need some sort of an optically clear petri dish, or that little test stand that I showed in one of the last where is it? Cuvettes here. So if it's in liquid form, that's how you would do it. If it's if you're drying it on a substrate, or it really depends on the sample.
Yeah. Angela, would you like to elaborate? I can allow you to unmute yourself. There you go. And then if you want to unmute yourself, there's a red circle with a microphone in it in your upper right-hand corner-ish. You can toggle that on if you'd like to chat and elaborate a bit. There you are. Yes. How are you?
Good. Thanks for taking the time to answer my questions. Yeah, so for our coatings, oftentimes they'll be more transparent, more clear than they when they're sprayed and cured than they are in a liquid sample. So it's always nice to check clarity in the liquid, but I'm just wondering, a lot of ours they're just waterborne, they're sprayed onto, not optically clear substrates. So I'm wondering if oftentimes too with tack coats. So I'm just wondering if any of that would affect the clarity, or if it would be best to just maybe do a drawdown on a piece of glass.
I would recommend that. And I would also recommend that you be as consistent as possible from one sample to another, obviously, because, you want to be able to compare apples to apples. And so whatever I would say that if you're using a glass substrate and you're doing a drawdown over that substrate, make sure that you're using the same one all the time, because of course the thickness, the quality of the glass, etc., is going to play a key role in the results. Keep in mind that you're also going to be measuring the transmittance of light through that glass substrate as well. So, if you do make changes, the thickness, the quality, if you've got something with inclusions and another part without, that will play a role. So as long as you choose a test method that allows you to be as consistent as possible from one sample to another, that's key. Regardless of what you do. And then, you may not be getting the absolute value of transmittance of that particular product alone, but you'll be able to develop a quality system based on its transmittance through the substrate and your product.
Yeah, that's really helpful. Is there a way, like with scales that we tear them? Is there a way to zero or tear the glass haze?
So tearing, no, but you can actually measure it without the substrate on it ahead of time to determine what the influence will be on your sample. There isn't really a way to tear it though, no.
Okay, so it would just be like take
it
the coating with the substrate minus the reading of just the substrate alone.
Right.
Okay.
Yeah. And keep in mind that any influences, like, there may be some intersurface, influences that might come into play as well. Again, as long as you're very, very consistent with the way that you're running your testing, that's key.
Yeah, with so many things with measurements and coatings, it's all about comparison and not necessarily like a hard value.
Exactly. And identifying, through quality, with quality control, identifying what passes and what fails, and then adjusting your tolerances accordingly.
Okay, perfect. Thank you so much.
You're welcome.
Great. Okay. Good points. Anyone else? I mean, if you want to talk about a certain situation, like Angela just did, just ping me too. I can unlock your microphone from this end, and then we can go from there. Or if you have any other questions, just log it in the chat, and we can take off there as well. There's Mike's email address. If you think of something after the fact, feel free to shoot an email to him, or like I said, just hit reply to any of the marketing messages, and we'll get it to the right people.
Yeah, and I'm one of many in the field, so there's I have colleagues throughout the United States that can help you as well.
Yep. If we have anyone from Latin America as well, we have some distributors down in Mexico and further south as well. So we can hook you up. Other, frequent questions you get out in the field, Mike, in working with folks?
No, a lot of it has to do with just, how, one of the other things that we do, and that I do on a fairly regular basis, is I will actually go out into the field and train people when they purchase this equipment, both the functions on the device and the functions of the software. So, a lot of my questions are specific to a lot of the questions that I get are specific to their industry, and how to set up the software, and how to run the samples, etc. So, it's it varies, but it's a lot of times it's just how do we set up standards, how do we and of course, with this interactive little system that I've got here, even if an in-person visit isn't possible in the near future, I can always do a Teams meeting and pull up this little little thing that I've got and show how to do it.
Yeah. No, excellent point. Yeah, it really depends on the substrate. It really depends on, getting the right process down so it can be replicated. So you are measuring that apples to apples, whether it's plant to plant or shift to shift. That's a huge part of it.
And we do manufacture a Haze Guard Eye Pro, which was developed specifically for very, very, very low haze, applications where you're dealing with. It's fine-tuned for applications where there is very little that's influencing light transmission, and you need to get a lot more accurate results. It was developed specifically for the electronics industry, specifically for cell phone glass and for that kind of application. So, if that's where you're working, we do have a product that's been really fine-tuned for that market.
Excellent. And yeah, it's, we do have a lot of expertise, people like Mike out in the field that can work and set up a good program for you, see what you're currently doing, maybe make some recommendations or suggestions on how to adjust things, but really, set that whole color appearance program in place for you, and we're always there to help. We have support folks. We have people out in the field, and constantly, updating firmware, making things better from a product standpoint, as well as a service standpoint, because it's all about you, the customer, and how we can help you do your jobs easier and alleviate some of the challenges and pressures you have. So, there's my marketing spiel. It seeps out every once in a while here, but anyway, I think unless there's any other questions here coming in, I think we've gotten them all.
Perfect.
But I appreciate your time and expertise, Mike. Thanks for jumping on this one. If anyone has any questions, Mike's email address is there. You can hit reply on a marketing message, and we'll get it to the right people. We have, let's see, I think we're doing gloss theory in our office hours next month.
Yeah.
We have a dispersion and media milling for energy storage or batteries. I think that's November 1. And then we have a kind of a wrap up year-end color and appearance in December. So stay tuned for more of those invites. We're also putting together a whole plan of these office hours formats, as well as our formal 60-minute presentations. We're getting that ready, and we'll be able to launch that right after the holidays. So we're getting down there, but I appreciate everyone on the call. Thank you for joining us, and have a great rest of your day. And thanks again, Mr. Peters.
No problem. Thank you. Bye, everyone.